So here's what. This is not a bunch of word problems. These are just little things. So here's what you see in a word problem. You see this dude right here. You don't have to write this. You're just looking at it. So we see that in a word problem, right? And here's how my brain works. I do this wrong. I think, oh, James is twice as old as his cousin. So I'm like, oh, that's 2J, right? But that's actually not the right way to do it. Here's what I want you to do. What I want you to think about this on when we're doing these is the first thing is I want you to give everyone a variable that makes sense. Do not use X's and Y's because at the end you're not going to be like, is it X a whale? Is it a dolphin? I don't know what it is. I'm going to use J for James and I'm going to use C for cousin. And I am going to try to equal them to each other. Right? So I want you to think about this. Right now, I'm going to ask you a question, and I'm going to want you to tell me, I'm going to raise your hand on one or the other. I want to know, just reading that, James is twice as old as his cousin, who is the older one? Is it James or the cousin? Raise your hand if you think James is the older one. Raise your hand if you think the cousin is the older one. You're right. James is the older one. So what we're trying to say is this. What we're trying to put is J and C together, and I want to make them equal to each other. I want them to be the exact same size. So if James Alexander is 18, he's not, he's 17, but let's pretend he's 18, and his cousin is 9, what would I have to do to the cousin to bump him up to James's age? Multiply by 2. For my brain, I have an easier time saying to myself on all of these problems, if I know the big amount, what do I have to do to the little amount to get it up to the big amount? Now, here's what's interesting. For some of you, you could do the other way. You could say, hey, I got James and I got the cousin. What could I do to James to make him the same as his cousin? I could cut him in half. But you know what? I don't like fractions, so I don't do that, right? So what I'd like you to do on your whiteboard, that's going to come around. I would like you to write a little equation for these next 3 things. I want you to take a J and a C and say to yourself, what do you have to do to C to turn it into J, right? Beautiful, beautiful, beautiful. Be careful of that last one. 5 less goes in the back. What did you think in the C? Oh, come on, why? Because I'm gonna throw you one in a second. Let's turn this up. While I'm walking, I can stop on your here. Do you know how to move it over? Multiply through, right?
Again.
Please, you have to zoom in here. Okay, here we come. I'm going to do it right here. So here we go. I know I want James and I want the cousin to equal each other. So I need to bump that cousin's age up by 3 times. Does that make sense? Could I do 1/3 of J as well? Sure, but I don't want to. Next one, James is 5 years older than his cousin. So here's James, here's the cousin. I want them to be equal, so I got to take that cousin and I got to add 5 years to him, and then he's the same as James. And on the last one, I got James and I got the cousin, but be careful on this one. To make them equal, I got to take the cousin, I got to times them by 2, and then subtract 5 years. 5 less than 2 times. Are we okay with that? Now, that's algebra 1. No lie, that's what we did in algebra 1. But I think a lot of teachers don't really drill down on that, so that's why I wanted to take a minute. But we're about to do some weird ones right now. And it's this dude. Let's see if I can actually move this, because I want to move these up, because this is my last period, so I can just kind of shove those up here. Okay, here we go. We're looking at this one. James has more money than me. He has 50% more money than me, right? So if you're just doing this problem, you would be like, oh, la, la, la. That's easy, Miss T. Here's James. Here's me. I'm Dana. That's my first name. You would say, oh, you take me and you times me by 50%, right? You would do that. Yeah, that's not good, because what does 50% do actually to my number? It makes it smaller, right? So that's not making me close to James. It's actually making me smaller. So percentages are weird. And here's what we're going to do. We're going to do this. We're going to say, if James has, I want to be equal to James. First thing is, I got to keep all the money in my pocket. So in my pocket, I want 100% of my money, 100% of my money in the pocket, right? I'm not taking any money out of my pocket. Then I'm going to add even more money to it. And you know what I'm going to add? I'm going to add 50% to it. Does that make sense? Let me show you what that's going to look like. Huh? Huh? Oh, yeah, I'm a teacher. I got nothing. So James is going to have Dana times 1.5. Does that make sense? Here's why. I get to keep 100% of my money. That's the one. And I add even more to it than that, right? Now, another way we could have done it for my smarty pants friends out there, we could have taken James. He would have gotten 100% of his money, but subtracted some of it. But I don't want to do that, because you know me, I don't like negatives and I don't like fractions. So when we have percentage, it's really easy. It's not just the straight percentage. You got to include that one, or I lose a lot of my money. So with that in mind, here's what I'd like you to try to do with your neighbor, if you would be so kind. Let me move this dude up a little bit. I would like you to write out for me the little equation on that one. And for some of my Algebra 2 trick friends, could you write it a second way by messing with James instead? If you want to try. You don't have to do that. All I want you to do for certain is give me James, mess with me to get me up to his amount. Nice seeing that. Love that. Love that. Perfect. If you did this, you are on fire. Here's James. Here's me. 1.4D. Nice and easy. Here's what you also could have done. If you wanted to be tricky, you could have said that James is 1 minus 0.4, or he would be 0.6 James equals me, right? It's a little bit tricky, but percentages are tricky because they seem like you're making things bigger, but you kind of aren't. Is that cool? So here's what we're going to do. We're going to practice 3 word problems in class. You can either just write them right along with us on your whiteboard desk, or if you want to get paper to write them down so you have them later. I think you just need to practice with them. I don't think that, I don't have like, here's, 18 million steps. You just got to practice them. So if you want to do whiteboard desk, that's fine. If you want to do paper, that is cool as well. Here we go, rock and roll. You ready? So let's start off with my girl Ella. Ella's buying some tiny animals. I'm actually going to make these pictures a little smaller because it turns out we don't have enough room. That is an adorable baby elephant. He is adorable. And does anyone, so no one's gotten this so right so far. Anyone who had me last year, I talked about that tiny little hippo. Does anyone remember his name? Do you remember his name? I do. His name is Fritz. And his mom's name is Fiona. And that's her. And that's Fiona. And she's pushing him up. He's learning to swim. So she's not sniffing his butt. She's under the water, you big babies. So here we go. We need 2 equations. And so what we got to do is look at our stuff and say, can we come up with 2 equations? So we're going to start like this. Ella buys. So first thing, step number 1, we need to make certain we've got variables. So you want to make certain you're going to make E for elephants, right? Do not use X and Y. I mean, obviously you can use X and Y. I wouldn't. And we're going to do H for hippos. Both, by the way, would be perfect to miniaturize. A miniature baby hippo would be adorable. Because otherwise they're super mean and they will drown you. So don't otherwise have a hippo as a pet. So here we go. Ella buys 3 elephants.
I didn't get that.
Yeah, too bad. Plus 2 hippos, and here's how much she spends. Now you can see why I let you have your phones today. Get those calculators ready to go. The math is not hard today. You might just need to use your calculator a little bit. That's one equation, but we need 2 because we got 2 variables. So we're going to read the next sentence. Hippos cost twice as much as elephants. This is that thing we got to get in our head. Hippos are more expensive. So we're going to take a hippo, and what are we going to do to the elephant to make it equal the hippo? Times it by 2. Are you good? Please, I'm going to walk around and watch you use a little bit of a substitution. Super, super easy. Everywhere we see an H, do not write H. Put in this dude instead. Right in there. Go ahead and get this going. Nice and easy. Don't forget, because it's free calculus, we don't get to just write some number like 7 and 12. You got to say elephants are blank, hippos are blank. Because I will ding you on a test if you just randomly write some random number down. Use your phone if you got them, because you all have calculators on your phones. You just learned what we did yesterday. So actually, you learned it like 3 times.
Why?
There you go, learn. And then remember, you say times it. Yeah, just multiply by 2. Nice and easy. It looks to me an elephant is that 1,490 bucks? Yeah, that's how much a tiny elephant is. It costs a lot to miniaturize an elephant. Jesus Christ, a dog costs 3,000 bucks. Now to get hippos, so easy. Just times it by 2, right? We're just going to double that bad boy. So a hippo is 2,000. How much?
2980.
2980. Boom. Go. How we do? Easy? Yeah. Let's get a hang of it. It's not bad. Next one I like a lot. I like putting these on because so when my kids were little, my sons are 9 years apart. 8.5, but right now they're 9 years apart. And so my oldest son would take advantage of Thomas. So I don't know if you've ever been around little kids. Little kids count money like this. So you can give a little kid a bunch of coins. You can give them a ton of coins, and this is how they count them. So they got nickels and dimes and pennies, and they count it like this. They go 1 money, 2 monies, 3 monies, 4 monies, and it's like they're all sorts of coins because little kids are stupid. That's how they count them. So what my oldest son would do is my oldest son would go to my little son's room who had money, and he'd see a quarter, and he'd say to my youngest son, can I have 1 of that silver monies, and I'm going to give you 6 of these monies. And he'd give him pennies, right? So he'd give him 6 pennies, and he'd take the quarter. And Thomas would be like, look at all the monies Michael gave me. And I'm like, oh, Thomas, someday. So, because that's how little kids count money. They count, and you know, it didn't matter. He was 3, and he was happy. He had all sorts of pennies. So he would go through. So the reason I'm saying that is because that matters here. We have 2 things happening. We have the little kid counting the monies. How many coins are in there, right? So we got some nickels, and we've got some dimes, and that means we have 129 monies, right? But we also have value, because when we're older kids, we realize that it's better to have a bunch of quarters than a bunch of pennies. I throw pennies away. I hate pennies. So here's what I know. On the next thing, this is how much they're worth. When we start talking about what money's worth, then we've got to put in how much a nickel is worth. A nickel is worth 5 cents. And a dime is worth 10 cents. And if you have, oh, I forgot the D. And if you put that all together, you're going to come up with $8.20. But before we do this problem, I'm going to tell you what. You know me. I don't like fractions, which means I don't like decimals either. Can I rewrite this equation and have no decimals? Is there a way I can do that? Yeah, I'm just going to multiply everything by 100. In other words, watch what happens. That just becomes 5. That just becomes 10. And the only thing you got to be careful of is just get rid of that dude right there. I have a lot of kids who will go 5n plus 10d equals 8.75. If you're going to get rid of decimals, get rid of all of them, right? So there you go. I'd like you to solve this. Lots of ways to do it. One way is you can multiply all this by -5 to make your n's go away. Or if you're super lazy, you could multiply it all by -10 to make your d's go away. Or you could use substitution. I don't care how you do it right now. There you go. While you're doing it, I'm checking in with these dudes. These are no overlaps. These are all overlaps. We want one part here, one part here, one part there. So this guy, this guy, this guy, this guy. And then you'll get like a 0.5, real easy to connect them out, right? Hey, on that one of those graphs, use intercepts, right? It goes one way, one goes the other. So beautiful job. Hey, let's take a look at this. Let's see what we did. I'm going to multiply everything through by -10 here. So I'm going to get -10n minus 10d equals -129. Does that look right? Yeah. So here's what I got. Put that underneath. I'm going to get -5n equals, I am going to pull up a calculator because I'm not even going to pretend to know that number in my head. I'm going to say 129, 0 minus 820, but I'm going to switch the sign. So I'm going to get -470. And then I am going to divide by 5. I got 94n. I got 94 nickels. Does that make sense? We have 94 nickels. How do I know what to do to get dimes? I just put it in here and subtract it from 129. So minus 129, and it looks like I have about 35 dimes. So the correct answer would be, there are 94 nickels. I did. And 35 dimes. So I took this guy right up here, multiplying by -10. -10, -10, -10. Because I wanted the D's. I wanted that guy to be square. Yeah. Are we good?
No, hold on.
Okay. We got one last one and then I'm shutting up. Hello, COVID friends. I think I'm down to like 1 or 2 COVID friends. Okay. Last one, best one. I love this last one. And here it is. It's James and I. And James Alexander and I have decided to buy pizza for a pizza party. Why not? But we don't have much money together. We only have 65 bucks. And so we're only getting Little Caesars. Pizza. So it's not going to be great, but come and have a piece of pizza with us. But the truth of the matter is I'm a teacher. I'm poor. I don't have much money. James has a lot more money than I do. So what we want to figure out is how much each of us are putting in. So Caesar, what would be your first step if you were doing this? D, yeah, that works. That's awesome. That would be a good way to start. Now, I need one more equation. And this next one is super easy. It seems like it's going to be tricky. Here's what I know. I know James is putting in some money. I don't know how much. I know I am putting in some money. And how much did we spend on the stupid pizzas? 65 bucks. And if you're saying, but Miss T, how come on this one, the other one when they have money, we have to do some weird stuff? Those are coin problems. That's when we're talking about monies. Does that make sense? But on this one, we're just talking about people throwing in cash. I don't know if he's using, maybe he's spending all pennies. Who the hell knows how he has his money? But there you go. So give this one a try. Now you're gonna be like, I'm a baby. It's got a decimal. You're not a baby. Guess what? Everywhere I see a J, I'm gonna plug in this guy, and to make it easy, just put a 1 right there. Yeah, I'll do it with you. 1.6D plus 1D equals 65. Nice and easy. 1.6 plus 1 is 2.6. We're not babies. We could do this. Equals 65. We got calculators. We're going to divide by 2.6. We're going to divide by 2.6. So I give only 25 bucks. Is that right? I give $25. That's how much I'm putting in. How much is James putting in? 40 bucks. He's putting in 40 bucks. So don't let the percentage ones fool you. You can totally do this. So here's what. Get your phones ready. I made an answer key today, and for the life of me, I copied it off and everything. I cannot find it. I walked in the room and I set it somewhere. So what I do have for you is I have a copy of it. So here you go. If you want to go ahead and take a picture, let's start up here, and you can grab a quick picture of that, and then I will give you another picture of the bottom part. And I'm going to pick some of these off because I think I did a little too many. And I know since there's not enough room to do the work on here. So either grab another piece of paper, do it on your whiteboard desk. Here's what, tomorrow, if you just have the answers written down and you don't really know how to do this, you're like, ha, I tricked her. And then when you take your test in a week and you miss them, I'm like, ha, you didn't. So that's